Hello everyone. I am making this video just to correct some of the stuff that we looked at in class in terms of the AA similarity condition or the theorem. The proof that we had in class today was not 100% correct, and so I went ahead and I changed it, and I wanted to go through it again so that we could understand what the proof was saying. So again, we're going to start with our givens here. We are given that this angle NML, which is right here, is congruent to OPQ, which is right there. Okay, so that's one thing that's given to us. The second thing that is given to us is that this angle, so that's this right here, is congruent to OQP. So that is this guy. Okay. Furthermore, this triangle here is a dilation by a factor of n of this big triangle. Okay, so since this guy right here is a dilation of the bigger triangle, if we can show that OPQ, that this triangle, is congruent to this triangle, and knowing that this here is a dilation of this triangle, then we can say that triangle OPQ, or POQ as they say here, is similar to MLN, to triangle MLN. So that's what we were trying to do. Now, it's important for us to know that this length here, or the dilation factor, is the length of PQ divided by the length of ML. And the reason why it's important is because we're going to use it in our proof. So let's scroll down so we can see the information for our proof. All right, same deal. We have our given information written right over here on their statement side of our two-column proof. So this angle, again, is this guy. And this angle, again, is this guy. Okay? Then it's also given to us that this angle, which is the same as this, because these are two dilations, these two angles are congruent to this angle over here. And those pieces of information are given to us. It's also given to us the dilation factor right over here. And the fact that this triangle is a dilation of that. That's given to us as well right there. Okay. We're going to use those pieces of information to help us prove what we need to prove. All right. So the next line is obtained by first. Actually, it is derived from this, because this triangle here, ML prime N prime, is a dilation of MLN. That means I can take the original length, ML, multiply it times the dilation factor, and get the dilated length. This comes strictly from the definition of a dilation. In this case, I would get ML prime, okay, which is what we have right here. Okay, that is a property of a dilation, as we are told right there. Furthermore, if we take our factor over here, our dilation factor, we know it to be N, which is equal to PQ, or the length of PQ divided by the length of ML. If I multiply both sides of my equation by the denominator here, on this side it cancels out on the right hand side, and on the left hand side I have ML times N equals the length of PQ. Now, notice that the length of PQ is the length of ML times N, but that also happens to be the length of ML prime. So we have shown that this length here is the same as that length, and that's what we needed to show. Because if we're able to show that, then we can use angle side angle theorem for these two small triangles, angle side angle, to prove that they are congruent. And if they are congruent, and this happens to be a dilation of this, then this is also a dilation of the big triangle, and which is precisely what we want to prove. Okay? So we have shown that that these are the same. Let's go in pieces though. Over here we're told this piece of information next. PQ is equal to the length of ML times N, right? And that's by the multiplication property, clearly, because that's what we did right over here. Okay. Now, we can say by substitution or also by transitivity, oopsie. Ooh, I forget how to spell it, transitivity, there we go, transitivity. We can say that the length of ML prime is equal to the length of PQ. Okay. And again, that means this length over here is the same as this length over here. Let me get rid of some of this stuff because it's kind of cluttering the place over there. Okay. There we go. Okay. Now going back to the, now this is where I was tripped up in class. This information and their justification was, I think transitivity or something like that. I don't remember. But actually, this information is given from number 2. If you look right up here, and I did some analyzing, and it's the exact same thing, right? And so really what they're doing is they're taking these two pieces of information, this angle, which is right there, and this angle, which is right here. Again, the one that corresponds with M is P, and they're congruent. It's given to us. And the one that corresponds, the angle that corresponds with L prime is Q, which is right there. And they are congruent. But we have shown as well that the length between those two sides, the included lengths right there, are also congruent because, here's our work, because of the fact that this little triangle is a dilation of the bigger triangle, and the dilation is performed in such a way that we get this relationship right over here, which is what we need. Perfect. So now we have angle side angle. We're able to conclude the triangle M N prime L prime, the little triangle over here, this guy, is congruent to triangle POQ, this triangle over there. And again, because this triangle is congruent to a similar triangle to our original big triangle, then this also must be similar. This guy over here also must be similar. And that's what the proof wanted us to get. I hope this has been helpful, guys. I know there's a lot of stuff going on, but if you take it slow, I think you guys can understand. And I'm sorry again for the fact that I didn't check the Edgenuity stuff before I printed it. I assumed it was okay, but now I know better. Thanks again for your patience, guys, and I'll see you on Thursday.